Hi, welcome to this session of the course. Today we are going to talk about one of the cybersecurity forensic tools. I'm assuming that you are familiar with the fundamentals of cybersecurity and cybersecurity forensic. In this session, we are going to introduce Autopsy. Autopsy is an open source cross-platform forensic tool. In order to download it, you may refer to this URL, which is this one. Here, you may download the installer program for Linux and Windows as well as macOS. We are not going through the installation process here, as it is quite straightforward. After the installation, you can run the program. For the Linux users, you have to use command line and your browser. The program provides a limited user interface in your browser using localhost and a specific port, which is 9999. Remember to open the program using the administrator privilege. This provides read and write access to all files and drives on your machine, especially if you are using Linux operating system. But if you choose the Windows, you will have a GUI, which is very helpful. I started with the Windows one. When you run the program for the very first time, you will see this, and you can choose the new case. Each case requires a case name and the base directory to save the database. The case number as well as the details of the examiner needs to be provided as well. This is my name, phone number, email, and perhaps some notes. It takes some time, and after that you may select the host name. Selecting the host type is in the next stage. Here we choose an image, but you have other options as well depending on your needs. Then we choose the image from its path. Selecting the time zone. It is used to generate a report based on the image you are analyzing. So it's better to use the time zone that is compatible with the image. It is also used in timeline. Now it's time to choose the ingest modules. Ingest modules are configured to find user content quickly. The ingest modules are grouped into pipelines. Each file goes down the pipeline module by module. A pipeline may have modules in the following order. MD5, that's for MD5 sum, SHA-1, these are hash functions, hash function calculations, hash lookup, file type ID, open zip files, exit extraction, add text to keyword index, and some more. Time goes by. Multiple pipelines may be running at the same time. By default, two pipelines are running. Parallel programming is used here to get the result more quickly. The analysis may take between several minutes to several hours depending on the size of the image. And now, the analysis is ready. I've done it before, and this is we have. I suggest using a virtual machine for analysis. The reason is that if you open an infected file accidentally, it may damage your system and files, especially when you have the same operating system. That's why I'm using a VirtualBox on my Linux. Anyway, analyzing the image thoroughly needs a long session. But we now talk about some aspects of the analysis. Timeline. Choosing the timeline is very useful to backward from the date that the incident happened. One of my clients once mentioned that she experienced some mismatches in the data on a server. I analyzed the server and its log files from the time we suspected the issue. I discovered that changes to these files had been made by a user who had left the office a long time ago. Soon after that, using the log files, it became clear that my client had granted access to this user on a specific date. She admitted that on that date, she had given administrative access to one of her trusted colleagues to perform a task on her behalf. Although she changed her password afterward, the colleague had created several backdoors for future use beforehand. So the cause of the problem was made clear. When using this timeline, by clicking here, you can also narrow your search. We use this here, all right? Keyword hits and keyword search is very useful. Suspicious activities such as phishing can be identified by using keyword hits and searching some particular words in the content of emails. Let's look at that. That's, for example, quickly, and these are files related to this. Communications. You can find the communications on the toolbar. These are emails on this image, in this image. This one here, and that's it. You can read the emails if you wish. By clicking here, email messages, and this one here. So you have the email. You can take this one a little bit above, and that's clear. As you know, phishing is a form of cybercrime where attackers deceive individuals into revealing sensitive information like login credentials or financial details by posing a legitimate organizations or individuals. Non-repudiation of emails is very useful to find the criminals who use email for their activities. Non-repudiation of emails means that as soon as they are sent, you cannot deny them. If you receive an email, you cannot deny it either. Data integrity, authenticity, and non-repudiation are in my research interest area. When you deal with these topics, the digital signature is of paramount importance. Digital signatures play a crucial role in modern day communication and transaction, ensuring data integrity, authenticity, and non-repudiation. Integrity is a fundamental principle in both cyber security and digital forensics, ensuring that data remains accurate and trustworthy throughout its lifetime. These are again emails. And this is suspicious files. Here we may find any file which are suspicious. It might be due to the extension mismatch perhaps. And as you see here, there are MD5 SOM and SHA 256 here, and you also have some more information about the file and the date it has been changed, for example, or the last time accessed or modified. You can use this one as well, that says the extension mismatch. Web history. If the attacker has a suspicious activity using the web addresses, you can find them here. You have access to deleted files as well. This one here, or perhaps here. Double click, and you got it. So these are deleted files. All right, I can find some files, for example, this one here. So as you know, if a file is deleted, as long as its space and the disk is not formatted, it can be recovered. When a file is deleted, the data is not physically erased from the hard drive, but the operating system removes the entry that points to the file's location. This makes the file invisible to the OS, but the data remains on the drive until it is overwritten by new data. And these are images and videos. If you click there, you can get those emails, those images and videos. Let's delete files again. All right. If you have any question regarding the topic of this session, you may come forward and ask your question at a later time. Thank you. See you next time. Bye-bye.